right, so hi everybody. My name is Ethan. Today I'm going to tell you about a problem that I've had for like 10 years, and I finally solved it, and I'm open sourcing it for all of you today. But before I get into that, just a little bit about me. I work at a company called Runway. We build our own world models for all sorts of applications like creative technology, robotics, and other things. In fact, yesterday we released like real-time characters that you can talk with, that interact with you, and like the whole thing's kind of wild. And there's even a Python SDK, so you can play with these. But so everything I'm going to talk about today was kind of built for the company, and I migrated the whole company over to this solution. So I've spent like the 10 years of my tech career working at like either training my own machine learning models or working with people who are training their own machine learning models. And so I spent that whole time kind of sitting here at the interface between science and engineering. And this interface, there's kind of like an inherent tension. So on one side, we have the scientists who, like kind of core to all of scientific work is experimentation. And so we need code and workflows that are flexible and iterative and things like that so that we can like tune all of our knobs and run as many experiments as possible. But then on the other side, we have the engineers who want everything to be robust and basically frozen so that it will not break in production. And historically, I think this has been kind of like a niche interface for machine learning practitioners, but I think that like everybody in this room now exists at this interface because like we have AI now, everybody's iterating on prompts and agents and harnesses and all sorts of things. And so historically, I think like the solution to the tension at this interface has been like a shitty compromise, which is often say like YAML files that are shipped back and forth between systems or even between teams. And I don't think it's a great compromise. But before I get into that, let me just talk a little bit about how we got here. And so like, how did we get to this place? Usually in the beginning, there's some sort of script that you write. Maybe you're just going to run this once in order to solve some problem. And so it might start with some like do everything script. So you run the script from the command line, do something to solve your problem, and then spit out some output. To make things concrete, let's take kind of like a modern example. Maybe we want to classify some text with an LLM. And so maybe in your do everything script, you start by just hard coding everything. So read this data, use that prompt, call this model, print out that score. And you think you're going to run it once and be done, but nothing's ever done. And so eventually you're going to have to run it again. And you're going to need to, twiddle some knobs there. And so oftentimes we reach for like a CLI to put in front of our code. And so the CLI becomes, the interface between the user and the code. And so now we can kind of parameterize our script with these different things. But again, this is never going to be enough. If you're truly successful, then you're going to want to improve things. You're going to want to be rerunning. You have stakeholders, et cetera. And so, you're eventually going to reach for some sort of configuration file. Ask me how I know. I've done this, unfortunately, at every company that I've worked at. And so you're going to build some sort of configuration file that you think is super smart. It's going to have all sorts of parameters in there that you can control much beyond how you could control a CLI. But now your script has to be updated with this configuration file. Your script has to be able to parse the configuration file, and like there's going to be this like implicit coupling between the whole thing because your script needs to kind of know the structure of the config file, which has its own implicit orchestration that lives in it. And so you do this whole thing, and you think that you're really smart, but then like again, it's going to get even more complicated. If you're really successful, you're going to build more and more systems on top of this. And you're going to put on your big brain hat, and you're going to be like, I got it. I got the ultimate abstractions that I'm going to build for my script. Because my script is now a DAG. And I have thought through the most glorious abstractions where each node of my DAG is going to be this beautiful class that defines the logic, and I'm going to have amazing interfaces, but I'm also going to still have that terrible config file in the front. So what does it end up looking like? Maybe you create some class to query some data. So maybe we have a SQL query class that's parameterized by a query, and maybe a start and an end date, so you can run it with different dates. But then how do you stick the config file in front? You do some reading deep into the YAML language. I don't even know what we'll call it. and you discover directives and tags, and maybe you invent some system to be able to dynamically instantiate Python classes from within your YAML. And you're like, this is it. Like, I've built the most glorious system. If somebody else can understand my configuration file, then they could program GPT-6 or something like that. But I'm here to argue that this is a terrible setup, and hopefully to propose a solution to it. And so there's a bunch of obvious reasons why this is bad. So like, if we're living in YAML land with strings that are referencing Python code, we get no benefit from our IDE. You can't like click through to the definition of a class or anything. You don't get type hints or validation. It's difficult to know what actual Python code is being run in your data pipelines or your training jobs and things like that. A bunch of other issues. But then beyond that, if you keep going, you're eventually going to create like a Turing-complete YAML, and at that point, maybe you should just use a Turing-complete language. But then there's also some kind of like subtle issues, and like it's maybe a bit of a hot take, but I would argue that these types of setups actually encourage worse practices in our software architecture. So like, if you want to use dependency injection, it's really difficult to do that if all of your classes need to be dynamically instantiated. And so everybody reaches for inheritance and just adding like flag after flag after flag to their classes. So I had all of these realizations a couple years ago, and I thought I was very smart, and I was like, tweeting things like this, like, let's all just use code. Let's just like write Python and like just create a data class or something, right? Like Pydantic. And so, at the time I thought, fine, I'll create a data class, and I'm just going to create my Python objects and shove them in the data class. Why do I need anything else to parameterize my workflows? But the problem here is that if I, let's say, construct this class, the SQL query class, how do I actually track what arguments were provided to the constructor? How do I know at what dates were run for this pipeline? And like, maybe you think that it's not important to track these arguments, but like last year, CoreWeave bought this company, Weights and Biases, for almost $2 billion, and like one of their bread and butter things was tracking arguments to functions and stuff like that. So it's an important problem. The other thing is that, like, what if these classes are expensive to instantiate? So maybe I don't want to create my SQL query class now because it might connect to a database. I want to wait until later. And maybe, again, you think that this isn't an important problem, but like, if you look up on Wikipedia, maybe GPT-4 had like 2 terabytes of RAM worth of parameters in it. And so if you're defining the config to train a legacy model like GPT-4, you wouldn't want to instantiate it on your local machine. You'd want to wait until you're on a cluster. And so then I tried to do this at a company. I put my even bigger brain hat on, and I was like, fine, I'm going to create this beautiful system where every class gets its own config, and I pass the class type into a data class, I pass the config in, and I can construct this later, and it's all going to be beautiful. But like, this also sucks too, because now you have to refactor your entire code base, and every single class has to have a config associated with it, and that's not great. Okay, so what do we need out of a system to solve all of this? I just want to write Python. I'm guessing many people here just want to write Python. We need to track our constructor arguments. We need to be able to lazily instantiate classes. And the last one is that I don't want to have to refactor my entire code base, mainly because at my job, I wanted to migrate everybody over to this, and I didn't want to have to refactor the entire code base. And so I built this library called Confingy, kind of like thingy, but fingy. It's on GitHub. You can go and check it out right now. You can pip install it, and I'll spend the rest of the talk explaining how it works. So it's relatively simple with small font. There's a little track decorator that you can put on top of any class. And if we put that on top of a class, if you go and instantiate that class, then Confingy intercepts the constructor, the init method, and it just tracks the arguments that were provided to the constructor in this tiny little private attribute called tracked info. And so by tracking the arguments that were provided to the constructor, we get some nice things. So one thing we can do is that any object that it's instantiated with this track, we can serialize it to JSON. And so we store information about, what was the class, what was its module path, what was provided to the constructor, even a hash of the class code. And so now we kind of get like a fully reusable workflow out of it. And in fact, it is reusable because you can then deserialize from that JSON back into the original class. And so we get this whole round trip loop. You can now do dependency injection. So if you provide a tracked class as an argument to another tracked class, then everything kind of gets tracked on that whole nested dependency chain. And so now I can go back and do my thing where I just construct my SQL query, or maybe I package that up inside of a data loader, and I package it up inside of a data class, and I package all of this up, but just calling my regular Python as I would. And now the entire thing can be serialized to like a giant ugly mess of JSON that is still deserializable back into Python. And so it's just Python. We track our constructor arguments. If you don't want to add decorators all over your code base, you can just wrap classes with track whenever you want to track them, kind of like functools.partial. And then the last step is lazy instantiation. So any class that's wrapped with track gets a special little method called lazy. And so if you call lazy with your constructor arguments, then nothing happens. You just create a lazy version of this class. It doesn't actually instantiate until you later call .instantiate. And so now we can lazily do whatever we want, which is what I like to do. The other nice thing with lazy, and this was annoying to get right, is that it's a generic type. And so everything's kind of like type safe, and your Python and IDE and MyPy can all kind of understand what's going on and understand lazy objects versus non-lazy objects and what they can do. So cool. We solved all the problems. We're done. But wait, there's more. Because we solved all of these problems, we get a whole bunch of other benefits that fall out for free. So one nice thing, shout out to Pydantic, is that we are tracking all of the constructor arguments. We also have type hints nowadays in Python. And so for free, we can, well, for basically free, we can run validation on all the constructor arguments. And so this is particularly helpful if you are constructing lazy objects. So if I construct a lazy object locally on my machine, it's very nice to catch validation errors there rather than wait until I'm on the cluster, after I've waited for my job to spin up. And so I completed all of that around last summer, and then I started to get into Claude Code and realized, as the kids say, I could just do things. And so I was talking with some coworkers, and everybody was kind of complaining about what I had built because this JSON is like very annoying to look at as a human. And yes, you can take the serialized model and you can deserialize back into Python, but now you just kind of have like a mess of bytes that exist in RAM somewhere, especially if somebody kind of hands you their serialized config. But I could stick Claude Code on this and ask it to build me a transpiler. And so there's a transpile function where you can take your JSON serialized config and transpile it back into the actual Python that would have produced it. And so now this is like fully back in human readable land. And so like when I have researchers that I work with who like train a model, they save a checkpoint, and they save their config somewhere, I can kind of reconstruct exactly the Python code that was used to run it. Just for fun, added an optional visualization server with FastAPI. So you can actually visualize your configs. You can diff configs in order to kind of understand what has changed in different versions of your pipeline. We use this for our data pipelines. We're heavy LansDB users, and we actually serialize the entire config when we calculate a new column, and we just store that as metadata. And so we get like Lineage and reproducibility for free. OK, so it's all great. It's all amazing. We're good to go. Not always. There's still some issues. So one is that there's pretty limited serialization support. I didn't really want to add too many dependencies. Really, all there is like Pydantic and Typer. Shout out again, because we ship with CLI. And so pretty much everything is just Python primitives. Embarrassingly, there's no Pydantic support yet, but maybe somebody will submit a PR. And also, all your arguments to your constructors have to be serializable. And so like NumPy is not supported. So if you provide a NumPy array, then that's not going to work. But in theory, we can add things on if we want. Also, Python doesn't like being fooled. And all this library is trying to do is fool it. It's like intercepting the init and like adding things on and trying to add attributes and methods while also still trying to convince Python that it's the exact same object. And so I found that I ended up having to use a MyPy plugin to get MyPy to be happy. For the life of me, I cannot get this squiggle away from the lazy. MyPy's happy with it, but Pywrite is not, and Claude tells me that it's not solvable. If you really hate squiggles in your IDE, then you can wrap something with lazy, and it's non-squiggleable. But yeah. And kind of the last thing is that like maybe some of you have heard of Hyrum's law, which is often related to like maintenance of an API. That if you release an API to the world, kind of like every aspect of it will eventually be explored by your users, and you will have to maintain every aspect that they can possibly access. I think there's a bit of a corollary here, which is that like if you give somebody a tool, they will do everything that they possibly can with the tool. And now if you give them a more powerful tool, like a Turing-complete language, then they're going to do even more things with it. And so like keeping complexity at bay is kind of like a never-ending problem. And with that, we're hiring. Please talk to me. Shout out to my colleagues who helped me a lot with this. And thank you all.